Welcome to Cheenta School of Statistics and Data Science. Today we are going to solve problem number 60 and 61 from the GATE 2022 statistics paper. So let us consider first the problem number 60. So the problem says that x1, x2, x3, x4 be a random sample of size 4 from a Bernoulli distribution with the parameter theta for theta lies between 0 to 1. So we consider the null hypothesis H naught theta equal to 1 by 4 against the alternative hypothesis H1 theta greater than 1 by 4. Suppose H naught is rejected if and only if the sum of the x size is greater than 2. So if alpha is the probability of type 1 error for the test and gamma theta is the power function of the test, you have to find the value of 16 alpha plus 7 gamma of half. That is the power function, the value of the power function at theta equal to half in integer. So to do the problem, let us consider the given facts. That is, xi follows IID Bernoulli theta for theta lies between 0 to 1, for I equal to 1 to 3, 4. And the testing problem is given by h naught theta equal to 1 by 4 against the alternative h1 theta greater than 1 by 4. The testing rule for the error testing problem is given by reject h naught if and only if summation xi is greater than 2. Okay. And alpha is the probability of type 1 error. So probability of type 1 error is probability that is because simply the probability of rejecting the null hypothesis h naught when that is given h naught is true. So actually h naught is true, but we are rejecting h naught. This probability is called the probability of type 1 error. So what is the probability basically? Let us see. So at theta equal to 4, 1 by 4. So because h naught is true. So since h naught is true, the value of theta is 1 by 4. And we have to find the probability of rejecting h naught. Rejecting h naught is basically summation xi I equal to 1 to 4 greater than 2. We consider x equal to summation xi 1 to 4. That is following binomial 4 comma theta distribution. So basically the probability simplifies to summation greater than 2 means 3 and 4. I equal to 3, 4. 4 c I and 1 by 4 whole to the power I into 3 by 4 whole to the power 4 minus I. So this simply becomes this, and the value is 13 by 4 to the power 4. So let us consider this one. Now we have to find gamma half. That is the value of power function of the test at theta equal to half. Okay. So this simply becomes the power of a test is probability of rejecting h naught given the parameter space. Okay, this is the power function, and at theta equal to half, this simply becomes probability of theta equal to half rejecting h naught. Okay, so rejecting h naught basically means x capital X greater than 2 at theta equal to half. So we put the parameter values and simply here. So here instead of 1 by 4, here is half. So this simply becomes 5 by 2 to the power 4. Okay. So thus 16 alpha plus 7 into gamma half is 13 by 16 plus 35 by 16. That is 48 by 16. That is 3. So the motive of the problem here is to find the probability of type 1 error and type 2 error. If we can calculate it, the problem, there is nothing much in the problem left, just apart from the calculations. Okay. So let us now focus on question number 61. Here the problem says that for random sample x1, x2, xn, normal population, consider obtained from a normal population, normal mu 2 square. Mu is the unknown parameter, which is the mean of the normal distribution, and the null hypothesis is h naught mu equal to 10. Is to be tested against the alternative h naught mu equal to h1 mu equal to 12. Okay. So the testing rule is given by if the sample mean is large. So how large is large? We will determine it by our method. Let us see. Then we have to find the smallest value of n such that type 1 error is 0.05 and type 2 error is at most 0.01. We have given some values. We will use it in the problem. Let us go to the problem. So here xi is our IID normal mu 2 square I equal to 1 to n. We have to test h naught mu equal to 10 against h1 mu equal to 12. The test function is given by phi x curl equal to 1. Indicator of xn bar is greater than c. Since xn is large, that is xn bar is large, what does it mean? Xn bar is greater than some constant. How large is large? That is determine the level of significance, and we will find the value of c from that. Okay, so to find the smallest value of n such that these two conditions hold, Probability of type 1 error is 0.05 and probability of type 2 error is less than equal to 0.01. With the help of these two conditions, we get probability of mu equal to 10 given xn bar greater than c is simplified to the normal 0 1 probability, that is mu equal to 10. We can simplify it xn bar by mu by the sigma thing and into root 10. Okay, this will simply greater than c minus mu by 2 into root n. Okay, so here mu equal to 10, so thus you can get this from the probability of type 1 error. Okay, so this will become, I guess, probability of x n less than equal to c. This will become 95. So from 2 also we get, we're doing the similar calculations, c minus 12 by 2 into root 10, capital phi of this thing is less than equal to 0.01. So this is become root 10 into c minus 10 by 2 is 1.645, and root 10 into c minus 12 by 2 is less than equal to minus 2.33. Since this function is given as less than equal to 0.01 and phi is increasing function, we have phi like this. Okay, this is 1, this is 0. So the since phi is increasing function, so fx less than equal to fy will yield x less than equal to y. Okay, so simply by doing that we get root n into c minus 12 by 2 less than equal to minus 2.33, and subtracting this we get minus 5 to 10 plus 6 to 10 greater than equal to 3.965, and n greater than equal to 15.8. That is the nearest integer value is 16. That is nearest, not nearest, but here we consider the next integer value after this. So this is 16. Okay, so the smallest value of n is 16, such that the required conditions are satisfied. Here also the motive is same, to find the probability of type 1 and type 2 error and implementing it via the normal probability laws and conditions. So that is all for today. Thank you for watching. I will see you in the next video. Till then, stay tuned and stay blessed.